Wow. To me, there's nothing cooler than a histogram. Greetings, folks. Welcome. The histograms that you just looked at do a great job of showing the distribution of a quantitative variable. Visual inspection can give us a pretty good idea about the distribution's shape, center, and spread. We can also calculate some descriptive statistics to give us a more precise measure of these characteristics. Let's start with some statistics that describe the center of a distribution. The two most common measures of distribution center are the mean and the median. We'll look at the median in this video, and in a different video we'll cover the mean. The median, which is also referred to as the 50th percentile, is the center of the distribution. That is, if you take a variable and sort it from smallest to largest values, the median value is the observation that falls right in the middle. If you have a variable with an odd number of observations, the median is the value of the observation in the n plus 1 divided by 2 position. So if you have 33 observations, the median value is the 17th observation in ascending order. So again, you take the sample size of 33, you add 1, that's 34, you divide that by 2, which is 17. So again, you find that median as the 17th observation. Here's a data set of people's ages with a sample size of just 5 observations. From smallest to largest, the values are 17, 21, 22, 24, and 72. So you have one old person that's in with a group of people that are in their early 20s, late teens. Since the sample size is an odd number, we add 1 to the sample size and divide by 2, which tells us that the median value is in the 3rd position, and the 3rd value in ascending order is 22. So the median of this distribution is 22. For a data set with an even number of observations, you still need to sort the observations from smallest to largest to find the median. But instead of using the formula n plus 1 divided by 2 to find the observation that's in the center of the distribution, you use the formula n divided by 2. This gives you one of the 2 observations that are in the center of the distribution. The second observation that's in the center of the distribution is the next highest value. We can write this as n divided by 2 and then add 1 to that. Since there are 2 observations in the center of a distribution when you have an even number of observations, the median is calculated as the average value of the 2. So here's an example. Suppose you have a sample of 4 people with the following ages: 22, 17, 21, and 24. In ascending order, the values are 17, 21, 22, and 24. Since the sample size is an even number, we'll divide that sample size, which is 4, divided by 2. So we'll look at the second observation in ascending order, which is 21. We then go up to the next observation, which is 22. And the average of 21 and 22 is 21.5, which is the median. Unlike the mean that can be heavily influenced by unusually large or small observations, the median is not affected very much by outliers. For this reason, the median is an appropriate measure of the center of a distribution when it's skewed. Again, this is because the median is resistant to unusually large or small values. In a different video, I will show you how to find the median of a variable using Microsoft Excel. But for now, I'll just go through the formula that we'll be using. If you have a variable that's in the cells B2 to B501, so this is a variable with 500 observations, the Excel formula for calculating the median value is equals median, parenthesis B2, colon B501. You close the parenthesis, then you hit enter return, and that gives you the median.